forgot to record for. Okay. Okay, now, anyway. Can you all understand? Positive and negative? Get it? So it's called lattice arrangement of alternating positive and negative ions. Oh, never mind. That's not that was recap. Okay, so it forms a giant lattice. Okay, so because every single electrostatic force of attraction is strong, therefore it takes a lot of energy to separate them. So the melting point and boiling point is very high. So sodium chloride is normal table salt. Okay, do you think if you cook in your house, will you able to melt table salt? Can you melt sugar in your house? Yeah, that's how you make caramel. But do you think you can melt salt? Unless you have an extraordinary stove lah. Because this melts at 801 degrees. You don't need to memorize this. I'm just letting you know. It melts at 801 degrees Celsius. Isn't that incredibly high? Yes, it's a very high melting point. 801. Yeah.
Like even like the salt we used to like
This is normal table salt. So when you cook, right, you don't melt the salt. You dissolve it in water.
there's a
Ah.
difference between melting and
Yes, there is a
yeah,
difference.
but so many people get confused with that though because they
Yeah.
like it's melting, dissolving,
So
this.
that's what we're going to learn now. Okay, so what happens is we're going to talk about them melting versus dissolving. Okay, why am I talking about this? There's a reason. We're going to talk about the next thing in a while. It's all in the same page. I'm just giving you some backstory. Okay, so melting is when, remember I told you about the positive, negative, has strong electrostatic force attraction, blah, blah, blah. Okay, melting means that I put so much energy that I'm able to overcome all of these until they melt to become free moving ions. Okay, so when it's melted, it's known as a molten. When I melt salt, it's known as molten. But if I melt ice, it's known as liquid. Right. So is molten the same as liquid? Aha, IQ question.
Isn't molten the liquid in volcanoes?
Yes, very good. Molten is the liquid in volcano.
Yeah, but
Why can't we just call it?
it's usually described as a liquid, but it's like yeah, it's like
Why?
it's a
Why do you
different
think?
compound, but it's the same.
It's like
but it's
moving rocks.
what? It's like yeah.
Okay, when you go to eat, there's this thing called molten chocolate shop. Okay, so they sell melted chocolate. Is melted chocolate same as a hot cocoa drink? No, melted chocolate is you take the chocolate and melt it. It's molten chocolate. Nobody calls it liquid chocolate, but is it liquid? Yes. So is molten and liquid the same thing? Yes. So how do we tell the difference? Actually, when we say something is
Like
liquid,
if you see it physically,
it's the same.
yeah.
But the thing that we use is the melting point, meaning that liquid means that it's a liquid at room temperature. Get it? So, for example, oil. Oil, do we call it molten or do we call it liquid? Liquid, because it's liquid at room temperature. Same like water is liquid at room temperature. Lava and molten chocolate, and this one we call it molten because we need to put in a lot of temperature to melt it. That's why we call it molten. But if in exam you see the word liquid, it's not that different. It's the same thing. But usually when we're talking about ionic compound, we say the word molten because the temperature is so high. Okay? Now, dissolving is different. Dissolving is here I have water. So what does water have? Teacher, water got water molecules lah.
Oxygen.
Yeah, but it has water molecules lah. Okay, so I need some more colors. Come on. I need blue. I got no blue. Okay, let's pretend the green color dots are water molecules. Okay, so water molecule is the green color dots. When I dissolve something, when I dissolve sodium chloride, what I'm doing is it doesn't melt, but the positive and negative ions separate and they go in between the water molecules. So when I dissolve sodium chloride, it is called an aqueous solution. Okay, so do you understand the difference between aqueous and molten? Molten is when I melt it into a liquid. Aqueous is when I dissolve it in water. Okay? Now, why am I telling you this? Because just now I told you covalent.
So wait. So molten is melting.
Molten is melting. Yes. Aqueous is when I dissolve it in water. Okay? So just now I just told you it has a high melting point, high boiling point. Okay? That is called a physical property. So if you look back at your textbook, okay, we're going to go back to the textbook. Now, okay, if you look back at your textbook and you see properties, okay, that properties, there you see this one is what we're talking about. The lattice formed by ionic compounds are regular arrangement of alternating positive negative ions. Okay. And then we were talking about properties that here. Can you see the word properties here? This is on page 173. Okay, properties of ionic compounds. They are usually solid at room temperature. Why? Because they have high melting point and high boiling point. Unless you are in the place of high melting point and high boiling point. Okay? Ionic compounds are good conductors of electricity in molten or in a solution. Next to the word solution, put there aqueous. Okay? They are poor conductors in solid state. Okay, I'm going to explain these two terms now. So you understand why they have high melting point, boiling point? Yeah, because they have strong electrostatic forces of attraction between the positive and negative ions. Why are they good conductors in molten or solution, but poor conductors in solid state? Okay, so I'm going to describe this explanation. Okay, chemistry, biology, and physics is actually not hard. It's just that you have to learn it once. Once you learn it one time and
Like
understand it,
biology and chemistry is just you have to memorize
you have to
everything.
memorize, but you have to understand. Once you understand it the first time, it's not so hard.
Yeah. Physics is different. You need to there's calculations. It's not just
Yeah.
I like physics rather than like biology.
Really?
I feel like biology is like I mean everything you learn in school is important, but I feel like biology offers like the most useful information.
Yeah, because it's your human body, right?
Yeah.
Okay. You okay? Can? Alright. So now let's look at this. Uh the question said that the property was high melting point, that one you already understand, and then the second property was conduct electricity. Okay, in order to conduct electricity, basically you need something to carry the electricity. Okay, now you imagine electricity is like people who need to go from one place to another place. So there's two ways of carrying these people.
It's electrostatic.
Not really. Okay, so you can use a car, okay, or you can use a bus. Okay, now you want to carry these people. The people can be carried from point A to point B using a car or a bus. Now, in order for it to be successful transporter of people, what must the car or the bus do? It must be able to move. Logic, right? It must be able to move. Duh. Right or not? But can you imagine? I tell you, okay, kiddos, come. I'm going to bring you to KFC. Picture how far is KFC? 10 minutes from here. How are we going to go? In my car. And then you all get into my car and then say, okay, that's it. Teacher, but we are not there yet. Yeah, my car cannot move. That's stupid, right? Okay?
The
That
whole
doesn't
thing
make
of
sense.
the car is stupid.
Yes. So ions can carry electricity. But in order for ions to carry electricity, the ions must move. Okay. Now, the notes just now said that in solid it cannot conduct electricity because in solid are the ions moving?
No.
No.
They're
In solid the ions are only vibrating in fixed position. So if I'm vibrating in fixed position, it's as if you all get into my car and then I just start the car and just going grrr, and it's not moving anywhere. Is it going to help? No. So solid cannot conduct electricity because of this.
It's like you're pulling the brakes on the car.
Okay, so in solid, the ions cannot conduct electricity because the ions are in a fixed position. But in molten and aqueous, just now I showed you, in molten and aqueous, are the ions moving? Yes, the ions are freely moving.
So for both molten and aqueous,
Yes, the ions are freely moving. In molten, you need to melt them into liquid. In liquid, isn't particles freely moving? Yes. In aqueous solution, the ions are separated and moving in between the water.
So can I write molten and aqueous solutions?
Can conduct electricity because the ions. So the thing is, the ions in molten or aqueous are freely moving. Can you understand? Okay, get it? Okay, you can write it in your notes also. There. So this part here, okay. Why? Ions freely moving. So if I don't show you that and just ask you to memorize, 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 nothing makes sense. Poor conductor of solid state is because ions not moving, but vibrate in fixed position, right?
Wait, do we have to write this in pen or pencil?
Doesn't matter, it's your book. Whatever makes you happy.
Because every other tuition I go to, there's a strict rule for you to take pen or pencil. That's why.
Oh no, you're not a baby. You do whatever you want. You can use highlighter, marker pen, what colors if you like, okay? Seriously, in tuition, they're so strict.
In my English tuitions, I have every day 1.5 hours for comprehension.
Why? The way you're saying this is as if you cannot speak English like that.
It's like a jail.
Yeah. Okay,
Don't
sorry.
worry, Yuchun.
That's so sad.
Yuchun? Yeah, I know Yuchun.
Is it at the language center?
No, it's at our place.
That's so sad.
Yeah, but the class is fun, so it's okay.
Okay.
There is daily homework though. Is it now? No, you don't. I mean, someone can.
Okay. Can you understand? All right. And then this one, we already know this one, right? Strong electrostatic force of attraction. So these kind of properties are known as physical properties. Okay, physical properties. Now, based on what you see here, can you add another physical property for me? Based on, okay, so high melting point, duh. Okay, can conduct electricity in molten and aqueous, yeah. But based on can conduct electricity in molten and aqueous, can you tell me one more physical property
About when?
about ionic compounds? It can dissolve in water. It can dissolve in water because the next compound that will
yeah, the solutions to
yeah
electricity, but only when they're dissolved.
yeah. So it can dissolve in water.
Wait, so it can only conduct electricity when it's dissolved.
Dissolve water or if it's melted. If it's solid, it cannot. So this is the first physical property. This is the second physical property. These two are one. These two are one. And then the third physical property is soluble in water. Okay, soluble in water. You okay?
Huh?
You look less tired than last week, but still quite tired.
What? Nothing's always like
Or is it how you look like Suyun all the time?
yeah.
Okay. Do you still have your English cap?
Oh no, it's all.
Oh, okay. No wonder you look
I
happy.
for 3 weeks. I read in 3 weeks.
Okay. All right. You guys understand? So it's soluble in water. Okay.
Everything. I have.
Now, remember just now I told you about the car and the bus? Okay, so one thing, so let's pretend that the car was free moving ions. Okay, car is ions. Okay, there is another thing that can conduct electricity, but it also has to be moving.
Circle.
What is in the circuit that makes it able to conduct electricity?
Wire.
What's in the wire that can make it? What's in the copper? We learned this before already.
Electric.
Close.
Electrostatic.
Close one. Close, almost. So close.
Wait.
Elect.
Electrostatic.
No.
Wait.
Shorter, not so long. Electrons. Thank you, my dear. Electrons. Okay. Oh, sorry, I didn't hear you. So electrons are another thing that can conduct electricity. But electrons also have to be freely moving. So I want to ask you something. In our ionic compound, are the electrons freely moving? No, they are not freely moving. Remember, the electron is just given one and then they're just standing there. They're not going anywhere.
It's different from an atom.
Yes. So the electrons are only free electrons is only in metal. So please don't confuse metallic and ionic. Okay, we're gonna talk about this later. We're gonna talk about this later. But the problem is students always get this confused. So just remember, ionic compound has ions. That's why it's called ionic compound. And
Ionic
the
compounds.
ions have to be freely moving to conduct electricity, and they are freely moving in molten or aqueous. That's it.
Ionic compounds
Have
have ions.
have ions, but they can only conduct when the ions are freely moving. Okay?
Which is a more suitable word, moving or vibrating?
You mean what? In the fixed position?
Yeah.
Fixed position use vibrate. Because if you use moving, it means it's moving everywhere. So vibrate means you must say the word vibrate in fixed position.
Oh,
Okay?
so I just wrote ionic compounds ions, but it only conduct when ions are moving.
Yeah, can. Alright. Okay. Get it? Get it?
Yeah.
Okay. Do you know why I put such emphasis on it? Because
It's important.
yeah, one is important. Two is my students always get it wrong, no matter how many times I put emphasize. Okay?
I mean,
So
fixing a habit does take some time.
yeah. Okay, so ionic compounds, high melting point, boiling point, they have a giant structure, strong electrostatic with the opposite charge ions, all directions. Okay? So a lot of energy to overcome them. So we told them about that. Ions are in fixed position in the lattice, they are therefore unable to carry charge. Ionic compounds are good conductors in molten and solution because the ions are able to carry a charge when they're freely moving. Okay? Can?
Wait, is this a third lesson? Like for me, sorry. Because last week and the week before. Isn't it the fourth lesson?
I have no idea.
Yeah.
I cannot remember.
I think it's 3 or 4.
Is today the third lesson or the fourth
Third
lesson?
or 4. No, for her it's
Second.
So okay, it's third because she joined 1 week
But I
after.
can't be, I couldn't have taught you the entire ionic compound.
We did
Atom. I think it's our fourth lesson.
4 cause
We did the atoms.
when we moved classroom and second lesson and third one. It's 4.
Okay. Okay. So the greater the charge, the stronger the electrostatic force of attraction. Okay? For example, MgO2 has a higher melting point than NaCl. So for example, I told you NaCl forms NaCl like that, right? So this has a melting point of 801. MgO will form a higher one. Okay. Now, what if aluminium and oxide? Okay. Let's say these two form a compound. Okay, remember how to do or not? So if it's Na plus and Cl negative, positive and negative can cancel each other out, so the formula is NaCl, right? If it's Mg, 2 plus and O2 negative, 2 plus and 2 negative can cancel each other out to become MgO. Do you remember? Okay, but if it's Al3 plus and O2 negative, is it the same number? No, so cannot cancel each other out. So what should I do? I have to swap it around, right?
So Al
So the formula of aluminium oxide is Al2O3. Now, do you think Al2O3 will have a higher or lower uh, melting point than NaCl?
I think higher or lower melting point.
Lower.
Come on, read this sentence again.
Wait,
Read this sentence again.
the greater the charge of the ions, the stronger the electrostatic force, and the higher the melting point be.
So NaCl.
So NaCl has a lower melting point than MgO. MgO has a higher one.
Oh. Wait, is it because the element in it is more reactive?
Yeah. So the higher, so will it be higher or lower?
Magnesium is more reactive, that's why.
Oh, wait. Yeah.
So
Okay, thank you.
higher or lower?
So it's higher.
Higher, yes. In fact, this has a melting point of almost 2000 degrees Celsius.
What?
Yeah. Try melt that.
So hot.
2000
Oh,
degrees
it's 'cause
Celsius.
Oh yeah.
Yeah, because Al 3 plus. Get it? Get it? Okay?
Like what is like the highest melting point that like humans can melt like in
Oh,
for as a metal?
I think it's about 3, 4,000. I'm not sure.
Oh,
I'm not sure because a blast furnace reaches about that temperature, a few thousand
That's
degrees
why it's
Celsius.
so fast. That's not.
wait,
Okay,
what?
Kim, you okay? Can understand?
What is like
Yeah.
carbons, like diamonds, like melting points? I heard that their melting point is quite high.
Yes, diamond is the highest melting point in the world. We're gonna learn that. It's not ionic. It's something else. We're gonna learn that later.
Or in Minecraft, when you just throw it in this lava.
Yes, okay. Minecraft is kind of true, as in how a blast furnace looks like.
Yeah, you mentioned first person.
Every single student can understand my furnace because of Minecraft, but the chemistry behind it is not true. You can't throw a diamond into a furnace. Okay?
Yeah, that you trying to do one thing. It's not do anything. Like
Okay.
you put the ore. Yeah.
All right, right. Okay. Let's do this. Okay. The reason why I'm repeating again is because I really, really want you all to remember this. Okay? So, one.
So an example of this one.
Yeah, I'm gonna do it now.
Is it a water or
Yeah, water is covalent. Okay, so you don't have to write it down again. I'm just showing you something just to recap. Okay? Now we're doing a lot of recapping. Why?
because recap is part of life.
Yeah, one other reason is because I teach a lot of dumb kids.
What?
Hey, you guys are not dumb, but I teach a lot of dumb kids.
You teach dumb
I
kids.
teach a lot. Oh no! Remember I told you about my boyfriend.
Imagine teaching my friends. There's like
Oh,
a very sensitive lesson today.
that was teaching one day.
Remember I told you about my student who after 4 months,
Okay, why am I gossiping? That's a bad habit.
4 months of tuition from 19 marks become 21 marks. And I told the mother I can't handle it anymore. I can't teach him anymore. So I taught him cell respiration, like a million times. I think my
Anaerobic or aerobic?
yeah, both. Just the word respiration, I told him so many times. So I finally was doing my worksheet and I said, okay, so in order to release energy, cells do cell. He's looking at me. I say, it starts with an R. Responsibility.
Oh no.
I mean, you do have to be responsible in a science lab, but it's not the question.
Okay, so group one, remember positive one, positive two, positive three. Do you know why I repeat it? I repeat it so many times.
Because
But
get it, and it's a very common
forget.
mistake.
Yeah, and they still ask me. So negative three,
Three.
negative. You don't need to write this down because we wrote it down so many times already. Okay. So
Right?
now we're gonna learn something different called covalent.
Coffee.
Okay. Group one, group two, group three. Remember, it is metal. This is like the sixth time I'm telling you, metal, 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 metal
Wait, so the groups are like transition metals and
are all
alkaline
metal.
metals.
Yes, that one you learn later on. Okay. So covalent.
It's not that I know, it's because the periodic table in my
Oh,
school
has it. Okay. So metals do not form covalent. Do not. No, never, ever, ever. Okay. Group 4, group 5, group 6, group 7 can form covalent. Group 8 never forms anything. Why? Because it has a full outer shell. Remember, it's very happy. It's very, very happy. It doesn't want to form
It's
anything.
in a rich country.
Yes, it's in a rich country. Yes, noble gases. Yes. Okay. All right. So
Wait, like I don't understand like the state of covalent.
no, we haven't learned yet.
Oh,
We haven't learned yet. Don't worry.
yeah,
Of course you don't
I
understand.
thought I was dumb.
No. I will tell you if you're dumb, okay? You're very good. We haven't learned yet.
Hey,
I'm just telling
you're not
you
dumb.
what forms covalent. Not yet. Okay. So why do I put it in group 4, group 5, group 6, group 7? Because of the, what is it called? Valence? Valence electron. What does valence electron mean? The electrons on the outer shell. Do you remember? So for example, carbon is in group 4. It has an electron arrangement of 2, 4. Remember? Nitrogen is 2, 5. And oxygen is 2, 6, for example. And fluorine is 2, 7. Okay, remember we did this before? Okay, so when you are in group 4, you have 4 valence electron, right? Okay, so this is where you're going to learn this. I'm going to teach you this. So what I'm teaching you now is group 4 has 4 valence electron. How many more does it need to be happy? four more, right? So because it has needs four more, it does not receive, does not release. Instead, it shares. And in order to share, it will form four bonds. Okay, this is what we're going to learn now. It forms four bonds. Okay. Now, group 5, it has 5 valence electron. That's why it's in group 5. If it feels like forming an ion, it will receive 3 to form 8. But if it doesn't want and it wants to form a covalent, can it form covalent? Yes. How many bonds do you think it will form? 3 bonds. Okay? So it goes the same logic. Group 6 has 6 valence electron. If it feels like forming ionic, it
So
will
it'll be
form
two bonds.
negative 2. Yes, very good. 2 bonds. Okay?
So it goes down. So
Yes, 7 bonds.
depending
And
on
1 bond, my
so
goodness.
the higher the number of the group, the less bond
Yes.
it makes.
Because the total has to be always 8. Remember, everybody's trying to achieve 8. Or if it only has 1 shell, it's only trying to achieve 2. Okay?
Fine.
It's okay, it's okay.
My book is
But wet, is it?
my book is like stick together.
Never mind, never mind. That means
Is it wet from the rain last week?
Yeah, I think it was.
I told you guys I need an umbrella, but no, you guys.
I did not. I have. She did not have an umbrella, so I felt so bad for her when she was standing by.
Oh, you're there to pick you up. Okay.
I mean, that's luckier than us. We just went through the rain. It's got all wet.
Okay, okay, it's not mine. So, to Kim, that's the beauty of having online class. You don't have to be in the rain. Okay, there's somebody that is not in any group that I haven't talked about. Get your periodic table. Somebody who's not in any group.
Uh,
Was
hydrogen.
Hydrogen, yes. Okay. And how many electrons does hydrogen have?
one.
One. So hydrogen has only one electron, one valence electron. It will form one covalent bond. Hydrogen is special. It will form one bond.
Oh
Okay.
wait, but like if hydrogen is like not in group, like what are they like also? Oh wait, never mind.
Hydrogen is special.
Yeah.
It doesn't have any group. Okay. Now, if you can remember just this concept, this whole chapter, you're very good already. You just need to know who forms ionic, who forms covalent. So, group 1, group 2.
Also, if you just know that, this part is easy.
It's like 80% of it. The rest is just drawing. The concept is all the same. Okay, so group 1, group 2, group 3 only forms positive ion, and it can only form ionic with group 5, group 6, group 7. Right? So if 1, 2, 3 is with 6, 5, 6, 7, it will form ionic definitely. But if 4, 5, 6, 7 is with 4, 5, 6, 7 and hydrogen, they form covalent. If these guys are with each other, they form covalent. Of course, minus the full outer shell lah. So if I give you an element that is 4, 5, 6, 7 or hydrogen, they will only form covalent. If you see a metal, 100% it forms a ionic. That's it. Okay? Such a simple concept, but so many people forget. All right? Okay.
It's a common mistake.
They forget, even though I've told them a gazillion, the billion times, like respiration.
Bit exaggerated.
He or them.
Um,
I'm pretty sure it's a bad.
it's a
Because it's not-
sometimes actually it's not dumb, it's really not dumb. There's no such thing as dumb or smart.
Yeah, it's just that
It's
that
not
everyone's
the name.
it's just that they
No,
live
them, yeah, because there's a variety of
everyone's in
students.
life that everyone is smart, but they just have a different way of
Oh,
learning.
it's like a nurture trust.
Yeah.
Oh,
Okay. So we're going to talk about covalent bonds now. Okay. And remember, the covalent bonds that we're going to talk about is only 4, 5, 6, 7 hydrogen react with each other. That's it.
wait, why does that the hydrogen doesn't have an ion?
It does, but we don't learn it now.
Oh,
We don't learn the ionic bond for
that's
hydrogen now.
like IGCSE. Right?
I think later on you will learn it.
Oh,
Later on when you learn. No. It's in IGCSE got, but I don't know whether this one got or not.
Oh,
I don't know whether it's included in this. Okay? All right, so Okay, this one is just theory. Okay, covalent compounds are formed when pairs of electrons are shared between atoms. Only non-metal atoms participate in covalent, so only non-metal. Okay, in ionic they gain and lose to form noble gas. Here they share. Okay, can? So there are two kinds, small molecules and giant molecule. Small molecule is like water. Giant molecule is like a diamond. Okay? So remember how I said diamond is the hardest substance in the world? So it's because it
It
has
likely depends on what kind of diamond it is because if the color of the diamond is light, it's very brittle. But if the color of the diamond is like very, how should I say, it's like
dull.
very, no, not dull, very strong.
Uh,
If it's dull, it's very,
actually the reason it's brittle is because it's something embedded inside it. That's why the color changes.
But why is like diamond like so hard? Like it looks like
Oh, we're gonna learn that.
glass.
We're gonna learn that. We're gonna learn why diamond is so hard. Okay? Alright, so when two or more atoms are covalently bonded together, we call them molecules. Okay, and then remember dot and cross previously we learned for ionic dot and cross. Covalent also got dot and cross. Okay, okay. Alright, okay. So these are all the examples. These are all the examples. I'm going to show you how to draw. Okay, I'm going to show you how to draw. So let's talk about hydrogen first. Okay, hydrogen. So all you don't need to draw because it's here. I'm going to explain to you how did it get here. Okay. So for example, hydrogen. Hydrogen is one electron. So is hydrogen happy? No. How many does it need to form full outer shell? One more. Remember, hydrogen only first shell maximum is only two. Don't go and say seven. Oh my goodness. Okay. So it talks to another hydrogen, which is also one. So this hydrogen says, give me. This hydrogen says, don't give me. No, you give me. No, you give me. No, you give me. Then they fight, and then group.
Oh,
So see, atoms are not very smart. So this hydrogen thinks it has two. Ha ha ha, I win. This hydrogen also thinks it has two. Ha ha ha, I win. So they both think they have two. So ta-da! So this is called sharing of electron. Okay, this
also if you have two
two.
of the same elements, you just intersect them and then it's just.
Yeah, but you have to see the bonds. So this is one pair of electrons.
are they
Right?
happy though?
Yeah, now they're happy.
Oh,
Okay, so it's one pair of electrons. Okay, one pair of electrons form one bond. So remember just a hydrogen form one bond? So it will look like this. This one line is how you draw one bond. Okay, so this is what is drawn here. You can draw it like this. This is the best way to draw it. Okay, sometimes you will see it like this. It is also correct. Okay, if they draw like this, can correct. Okay, but I will not encourage you to do this because sometimes you forget. I will encourage you to do this one. It's better. Now, I'm going to draw something. I want you to tell me why it's wrong. If I draw like this. Because both are in one electron, one atom only. So cannot. Okay, so when you draw like this, you might accidentally draw like this. So that's why I encourage you all to draw like this. Get it? Okay, so this drawing, so much prettier, right? This is called dot and cross, right? What is this called? This shows the bond. This is called display. Okay? Okay? The one with the line is called a displayed formula. The one with the dot and cross is called dot and cross. Sure, am I supposed to memorize all this? No, no. I'm going to explain to you why they form like this. Okay? Don't go and memorize. Okay, so you don't need to draw on this. I'm going to show you another empty page so that you will understand how they get to this. Okay? So this one is dot and cross. This one is displayed. When I write like this H2, what is it called?
Two hydrogen.
This is known as displayed formula. This is called dot and cross. Then if I write H2, it's called what? H2 lah! What is it? What is this?
Two hydrogen.
No, no. What is it called? What kind of formula do you think? You're going to laugh when I say it. Molecular formula. A molecular formula is a formula that shows the actual formula lah. So in this case, what you think is the formula, molecular formula of this? NH3. This is called ammonia. Okay, and this one is CH4. This is called methane. Okay, okay. So what I'm going to do is I'm going to teach you how these came about. Okay, and water is actually slightly different. I'm going to explain in a while. Okay, yeah. Okay. Okay, we'll take a 2 minute break when it's 3 o'clock. Okay, so that you can rest your brain a bit. Okay.
Sometimes you say 7 minutes, sometimes you say 1 minute, sometimes you say 3 minutes. So
Let's stick with 2 minutes. No lah, I say 2 minutes. By the time you actually come back from the bathroom and everything, it's 5 minutes already.
No, I don't spend that long.
Okay, NH3, CH4, and water. Okay, and what's the next one? And not HCl. What's it? HCl. CL. Okay. Okay, now okay, nobody is going to ask you to memorize these molecules. If someone asks you to memorize these molecules, you will go mad. How many molecules can you memorize? There's so many different kinds of molecules. These are just examples. So you just need to know how it's formed. So when the exam, they give you a random molecule, what's the first thing you do? Let's say they tell you nitrogen and hydrogen form a molecule, draw. The first thing you do is you write down the electron arrangement. So nitrogen is 2, 5, hydrogen is 1. Again, no need to memorize. Look at your periodic table. So you know that nitrogen needs 3 bonds because I just told you, and hydrogen needs 1 bond. So this means that nitrogen is a kind of creature that has 3 hands. Okay? Alright, and then, how did that happen? Oh my goodness, that is so cool. I did this, and the reaction it came out by itself. Okay, I know maybe you guys have done this before. Did you see that? I just did
there's
this.
like a special effect, but
No, you can do that.
No, I did not know either because I haven't used Zoom in so long.
That's so cool. Okay, sorry. Maybe
there's when you spam a lot of emoji, there's like a special
I
effect.
wonder what else can it do.
One of my online English tutors, people were spamming 6.
It works. Seriously. Okay, sorry guys. I'm just like it's like I've never been so exposed to technology.
What? I live in a technological world.
Maybe when I go home, my fridge will talk to me. Okay,
Yeah.
so
Lucky.
okay, focus.
I don't like it.
Okay, now
I'm
and
old-fashioned.
H3. Yeah, I'm old fashioned. I don't like my computers talking back to me. Okay, NH3. So can you see there's 3 bonds? Okay, now we only need to draw the outer shell. Unless the question says anything, we only draw the outer shell. So we are only drawing 5 and 1 lah. Okay, so what you must remember not to forget is here 1, 2, 3, right? Okay, a lot of students make this mistake where teacher, hydrogen, 1, 2, 3 dot. Yes. Nitrogen, 1, 2, 3 cross. Ta-da! What am I forgetting? Nitrogen is supposed to have 5 valence electron. You're forgetting this.
Yeah.
How do you check that? Nitrogen is trying to form 2, 8. So it must have 8. So you look at this. 1, 2, 3, 4, 5, 6, 7, 8. Okay. That's how you know it's correct. Make
So
sense?
that's the
That's how you see.
covalent compound.
Yes. So the covalent compound is ammonia NH3. Make sense? Okay. Now let's look at methane. Okay, methane. Okay, methane CH4. Again, don't be lazy. Even if you are so like pro in doing this, always do this. Because you're gonna suddenly forget. Okay? Now, carbon is a creature that must have 4 bonds. Okay, how do I know that? Because 4 valence electron must have 4 bonds. So hydrogen must have only 1 bond. So they're happy lah. 1, 2, 3, 4. Okay, so I need to draw this out. So carbon in the middle and then 4 hydrogen around. Get it? So 1, 2, 3, 4. 1, 2, 3, 4. That's how it works. Can you understand? Okay. Get it? Okay, now water is H2O. Okay. Now, if you draw like that in exam, your water, it's not wrong. It's not wrong, but it's wrong lah.
What?
As in,
It's what?
He
in
said it's not wrong, but
it's not, that means that they won't penalize and minus mark if you draw like that. But in theory, in reality, it doesn't look like that. Okay? Because water, right? Water is 1 and 2, 6. One bond and 2 bond. Okay? So the oxygen should like cold lah. Cold is it?
No.
So the one in your book looks like this. Okay, it's not linear. It looks like this. Why? Because if it doesn't look like this, right, there's no life on Earth. Water is actually very, very small molecule. You see this methane, this methane and ammonia. Okay, ammonia is NH3. Do you remember how to count? Like nitrogen is 14, hydrogen is 1, so it's 17. You remember? Okay, you don't remember, it's okay. So ammonia is actually 17. So this mass is very little, so it's actually a gas. Okay? Methane is CH4, carbon is 12, hydrogen is 4. So it's 16. Wow, it's even smaller. That's why methane is also a gas. Methane gas is the one that we use for cooking at home. The cooking gas. Cooking gas is filled with methane gas. Okay? And then water, H2O, is actually even smaller. Hydrogen is 1 times 2 plus 16 is only 18. So in reality, if in theory, right, water is 18, so water should be a gas or a liquid. A gas. But why is it a liquid? Because water, the shape of the molecule is special. It's actually V-shaped. Okay? The molecule is actually V-shaped. So what happens here is, I mean, they won't penalize you for drawing it linear, but it's not linear lah. You live on Earth, which is 70% water, you should know.
Oh, but like Mr. Function would penalize it.
No, yeah, your teacher might penalize it because they're so strict. So hydrogen is 1 only, right? Okay, like that. Now, oxygen is 1, 2, but total has how many? 6. So it's actually 4, 3, 4, 5, 6. So the electrons are up here. That's why they push the hydrogen down. That's why it has a V shape. Understand? So can you please draw this next to the one that you have? Because if not, you'll be so confused. Why teacher draw different from the book? Okay?
can I draw on the bottom of the page?
Yeah, yeah, sure. You can draw
even at
anywhere.
the top, I don't have enough
Yeah, yeah, it's your book, your book. You can draw anywhere.
Later, do you want to see my edits?
What?
Of edits.
Hopefully it's better than one face.
Bro, want you to see make that.
Okay. Ready?
Yeah.
Wait.
Make sense? Make sense? Do you understand the dog covalent?
I
Okay. Now, okay, I want you to take note. Everybody here, how many electrons do they share in the sharing part?
8.
No, no, each one is only one pair. So when you share one pair, you don't share one electron, ah. You cannot share one electron. It's like sharing one lollipop. Yeah. But I lick one time, you lick one time, you cannot, right? Alright, so share one lollipop. We share two lollipops, different flavors, for example. Like I give you half, I give you half like that. So they don't share one electron, they share one pair. So when they share one pair of electrons, it's called a single bond. or a single covalent bond. Okay, so a single covalent bond is shown by this just one line. So all of them in your book are one line, one line, one line, right? And that one line, it means single bond. Okay, can you understand?
Yeah.
All right. Hi.
Yeah, sorry, can I get a protractor?
Oh yeah, yeah, sure, 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 sure. Here,
Yeah.
you're the one who put it here.
Yeah, for my kids.
Yeah, I think don't know. I think after half you.
I put like 5, 6 inside.
Yeah, really, you think. Okay, can understand, guys?
Yeah.
Can okay, so can you see the one that says chlorine? The one that says chlorine. The next one, the one in your notes. So the next one is chlorine. So chlorine is two.
Oh wait, on the bottom left.
On the bottom left. Yes, the ClCl. So 7 means one bond. Okay, so it will form like that, chlorine. Okay, is it correct to say that if you have the same valence electron, you will look exactly the same? That means chlorine and chlorine, it will look like this. 1, 2, 3, 4, 5, 6, 7, 8. Ta-da! I share with you. Okay. Now, they will look like this, right?
Wait, why do you put that one as X's but
It doesn't matter. It doesn't make a difference. Yeah. Now, if I tell you fluorine and bromine, will they look exactly the same if I'm only drawing the outer shell? Think first, think first.
yes, they will.
Will they look exactly the same? Yes. So those in the same group will look the same because they have the same outer shell. So if I don't want to draw fluorine and I said the question is actually asking me to draw bromine, it will look exactly the same because the outer shell will be the same. Make sense? Okay. Okay. All right. No, then HCl, no need to know. It's same thing lah. Okay. I want to challenge y'all. Okay. That's why I erase a book, Robin. Okay. I want to challenge y'all to draw something a little bit different. Okay. Now, listen first. If you need paper, let me know. If you have no notebook or whatever, let me know. Okay. I can find paper for you. Okay. Now, this is a little bit of a challenge. Okay. First of all, you need to think whether it's ionic or covalent. Okay, can? So what happens is sodium, okay, and nitrogen forms a compound, okay, and then nitrogen also forms a compound with fluorine. Okay, do you understand the question? Fluorine forms a compound with nitrogen. Sodium also forms a compound with nitrogen. Okay, yeah. I only want you to draw the dot and cross diagram. Do you remember what's the dot and cross diagram? Okay, if you want to draw the displayed formula also can. You want to write the molecular formula also can. But I want you to draw the dot and cross for fluorine and nitrogen, sodium and nitrogen. Okay? What is your first step? Write down the
The number of electrons.
electron arrangement. Yeah. Okay. Do you know what to do?
I think so.
Kyokim, you know what to do?
Yeah.
Okay. Okay. I really need to go to the washroom.
Um, several large apart comes by emotion.
You're supposed to draw the one with the circles. Like, the dot and cross is basically what I was showing you all this while. Okay? You get it? So you're supposed to draw the dot and cross diagram. Dot and cross diagram is all of this. Wait. It's all of this. This one. All these that I've been showing you. These are all the dot and cross. This one, this one. For covalent, it looks like this. For ionic, do you remember how it looks like?
Yeah, with hydrogen, it's easier, but with
Okay, do you need help?
yeah,
Okay, maybe I'll teach you how to do the first one. Okay, you all look like you're gonna cry already. Okay, don't cry, don't cry.
no, it's not that. It's like
It's okay, it's okay. Okay, Joaquin, do you manage to do? You want to send me what you done?
Oh, I didn't do it.
Oh, you didn't? Okay, okay, okay. Maybe my example was too vague. Okay, never mind. Fluorine 2,7, nitrogen 2,5. Okay, sodium 2,8,1, nitrogen 2,5. Okay, let's ask the first and most important question. Sodium and nitrogen form ionic or covalent? Sodium and nitrogen,
Yeah.
ionic or covalent?
yeah,
Ionic. That's the most important thing to remember. Ionic. Okay. Fluorine and nitrogen is
uh, covalent.
covalent. Okay. So, fluorine, how many bonds? One bond. Did you get that?
Yeah.
Nitrogen, how many bonds? Three bonds. Okay. Does it look like this? Does it look like this? Yes? Yeah? Okay, that's the first thing you must know. So it must look like this. That's not the dot and cross. The display looks like this.
Oh, what about where did H come from?
Oh, sorry, F. Sorry,
Oh,
F. Sorry, I didn't realize I wrote H. F. Okay. Hey, teacher, this looks like ammonia. Uh-huh. Same group, same kind of bond. So just have nitrogen in the middle. And you have three fluorine at the side.
So that's it.
Wait, now I haven't drawn the dot and cross. So fluorine is, oh my goodness. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I feel like a dancer. 1, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Okay, don't just copy. Do you understand? Do you get it now?
a little bit.
A little bit? This is how it's supposed to look like.
Okay. Eight. Trombone.
Okay, do you understand? Do you understand? Okay?
Wait, so the one on the left is dotted across, and the one on the right is
This one display.
split.
Hmm. That's why it's good to have notes, but I prefer you not having notes and I make you draw. Because by the time we are drawing this, you'll have drawn 5 already. You get it? It's like that. But no notes, then you have to draw and draw and draw. So, okay, so sodium,
So sodium would have
2, 8, 1 becomes 2, 8. Right? And then nitrogen, from 2, 5, it will become 2, 8.
We
1, 2, 3, 4, 5, 6, 7, 8. Why is it dot? Because it's from the other side. And 3 negative. The formula will be Na3N, but you need to draw three nitrogen, three sodium. Okay, are they both dot and cross?
Um,
Yes, the difference is this one is ionic, this one is covalent. Okay, I'll take a 2-minute break. During this 2-minute break, you can digest this information or you can take a break. Okay, but if you don't understand, you take these 2 minutes to digest this information. Okay? Do you understand? Can?
Yeah.
Okay. We're gonna do one more in a while.
Chemistry is a big topic. I mean, like,
Yeah,
isn't that true?
yeah. Because the reason why is because they said
There's so many properties.
yeah, they mentioned that in your GIS, your school, the chemistry and biology component is very big. So that's why we're teaching it like earlier.
Oh, chemistry is bigger than biology.
Is it?
Yeah.
Why they teach so much chemistry? Or does it change if the teacher changes? Or is it like fixed already like that?
I'm not sure. Every teacher's teaching style is quite different.
But even though the
Can I
teachers,
just step back?
yeah, you can go to the back. Okay,
So you can show me your editing.
I have 185 subscribers.
oh no, why did I do it twice?
What?
It's the same thing. Sheesh, I didn't realize.
What?
It's the same thing. I didn't realize I already uploaded the class. Yeah. It's for my student. They missed the class this morning. Okay, we wait for Jeff to come back from toilet, then we can start. Any questions? Any questions? No. Ah? Okay, can I start, guys? I give you exactly 2 minutes. All right? Can? Okay. Can I do one more that is similar, this concept? Can I? Okay. So, amplifier and hydrogen.
Can I have another sheet of paper?
Yeah, can.
No, I don't even have sheet.
Do you need? Do you need?
I don't think I really need it.
Okay. You have a place to draw? You have your own notebook? You have a
I'm
place
just
to
gonna
draw?
lose it again, so I don't really. Okay. Just gonna lose it anyway.
Okay. And then sulfur and
Oh shit. Oh,
potassium. Okay. Do you know what to do now?
yeah.
Okay. Show me what you got, guys.
Wait, I forgot the like.
Look at your periodic table to write down the electron arrangement. Sulfur is S.
Yeah, I saw.
Potassium is K. I'm not gonna like push y'all so hard because it's something new for y'all. So slowly we'll get used
Oh
to it,
shit,
okay?
no, I forgot to make an electron.
Electron arrangement. The first shell has two, the second shell eight, the third shell either 8 or 18, the last shell, but the outermost shell must be between the numbers of 1 to 8. That's all.
Wait, for sulfur, is it 277?
No! It's the inside shell, it's 2, 8, 6, of
Oh, it's
course.
286.
You must fill in the ones inside first. Okay. 2, 8, 6, and this one is 1. Okay? So sulfur 286 and potassium is 2881. You actually, if you really forgot, you just need to look at the outer shell.
Oh. Hydrogen, you think? So do we draw dot and cross?
Yes, draw dot and cross for both. Same concept as the one I just taught you. Can I see? See. So dot and cross. The other way around. It's completely wrong.
Oh, okay,
So
so
what should you do? Because sulfur needs how many bonds?
6.
2. Remember? 2 bonds there, the one you trace out. 2 bonds, literally.
Oh, because it's invisible.
Ah, sulfur needs two bonds. Hydrogen needs how many bonds?
One.
One. So it should look like this. Try again. And this one is a metal, so this one is ionic, not covalent. Okay? So you need to draw the dot across. I think you need a piece of paper. Mm, you almost very weird lah. Because okay. Okay, this correct to draw the dot across from here. And then this one is ionic, not covalent. Did you draw just now that one? Huh? The one that I drew for you just now? And then calcium. What is this?
No, that's okay.
Is two. Eight. Eight. Two. Why did I ever issue two eight? Can we go for this? These are all wrong. Like this is two eight two. Let's calculate theories. Aluminium is 283. The first shell is 2. The second shell must be filled with 8 first. Then only you have the outer shell and you must follow the valence electron. I know energy. How do I do it?
So,
Did we discuss this? Did we discuss this in class?
what?
Did we discuss this in class?
Yeah, that's
Ah.
I did not know what to do.
Yeah. That's of it was yeah, I don't understand what. I don't ask you randomly give answers. Oh, and then we get how you dream. How you daydream.
I can.
Love that. Love that. And for every single thing on board. What's your paper?
Oh, I don't have it.
You didn't come last week?
I know I came last week, but like I keep losing it because I have to like I have like math tuition here. Can I have like the math? I have to like
Guys,
change the backs.
you guys have to step up. You are not stepped up yet. Okay? Okay, it's okay. Do you know what to do? Can you send me what you did on WhatsApp?
Like, I'm not really sure, but then I just drew it.
Wait a minute. Just show me, just show me. Yes.
Should I send you a picture?
Yes, please send the picture.
Okay.
Are you guys so used to people scolding you that if I don't scold you, you don't learn? What? Dude, seriously. Why did you draw so many? Every single one is like an electron. Oh. Right. Draw him. Oh. You still draw the dot across for this first.
Oh, so then it's hydrogen also.
How what is this draw? Did you draw the one just now? You know what I just did? Okay, so. Oh. Hey, you cannot give me kindergarten work. You already in year 9. Okay? So you're supposed to draw this side here, convert this into a dot across. That's it. And you don't know because you were not listening when I was discussing on it. Okay? Screaming and talking at you. Okay, this one will be ionic or covalent.
Ion.
Ionic. So write down the electron arrangement first. And I even wrote the electron arrangement on the board for y'all. It's correct. No,
the one on the right is correct. The dot and cross on the hydrogen and sulfur is correct. The potassium sulfur, you have to choose one. Which one do you choose? You can't show me both. Only one is correct.
I'm like kind to the left.
The one
Left.
with the box is correct. Yeah.
Wait, what? Wait, what?
Okay, so the hydrogen sulfide, it's not like this. It's not like this. Okay? This one is only for covalent. Okay?
Oh,
And then so sulfur, you're drawing 286, right? Then you drew 8, correct? The other two you must show it's another kind of electron. Okay?
wait, what do you mean by the other two?
Sorry?
Wait,
That
what do you
means
mean by the
two,
other?
that means two wait, let me show you. So like this one, right? Here is from oxygen. These two are different. It shows it's from the magnesium. Like that. Can you see?
Oh, yeah,
So oxygen is 2, 6. 6 is here. 1, 2, 3, 4, 5, 6. The other two come from magnesium. So that's why these two look different. Get it?
yeah.
Yeah. So you try again. Try again. Just draw the
Wait,
outer shell. Just draw the outer shell.
what? Try the potassium.
No, sulfur. The sulfur you got it wrong. The sulfide.
Wait, sulfur and the hydrogen? Because there's like
The-
two sulfurs.
This one you did wrong. The sulfur ion. This one.
Oh,
This one. The sulfide ion. This one you did correct. This one also correct. This one you don't draw the one. This one you drew this, right? Or something like that. That one is wrong. The other one with the box is correct. Okay? Do you
yeah,
understand?
yeah.
Okay, hydrogen has how many electrons, my dear child?
And what?
Why are you doing it?
I think so. Yeah.
Sulfur in the middle. Mm. Next time you need to sit right in front of me because you're making up your own theories and you're in your la la land. Okay, this one, notice ionic, last week's one.
Yeah, you can figure it.
Okay. Write down the electrode arrangement. Okay, so this is positive, this is a negative one. So sulfur had no wait. Sulfur is 286. You only do 2. Where's the other?
Oh, so I did 2, so I need the other 8. Wait, no, so it's 286.
So you already drew 2. So how many more you need?
I needed 2, so I will do 40 degree.
It needs 2. You already drew 2.
So you don't fall on the view for me.
No, you draw it on sulfur.
So we want to be
Yes. And these two also come from sulfur. Do you get it now?
oh,
Do you get it
okay.
now?
Like that one comes from sulfur, and this one is
Yes.
individual for hydrogen. Okay.
Yes. This one is this one. This, but you cannot it's one. So can you please pause on this and write these answers down for you?
Show me.
Hmm.
I did agree with the answer.
Okay, boys, you have to up your game, okay? I school you something you can do already. Alright? 286 becomes 288. Why you got so many? What? What do you mean so? The dot belongs to here or the dot belongs to here. Who now choose?
Oh, potassium.
Potassium has a dot. So if potassium has a dot, 288 is all dots. You don't need to draw 288 if you don't want. You just draw the outer shell and fine. But it has to be all dots. And then bracket +1. Right? Now sulfur, let's just draw the outer shell again. Okay. 2, 8. So the inside 2 has to be crossed to show it's different. 6. 1, 2, 3, 4, 5, 6. The last two come from here. And then it is 2 negative. Get it?
Yeah.
Draw. Okay. Next class, the two of you sit right in front of me. Okay?
Okay.
Dude, guys, come on. She came like last week and she knows what to do. Okay. So sulfur, 2, 6. So you draw like this. I'm gonna make you all draw another one. We're gonna draw until you see stars, okay? So 1, 2, 3, 4, 5, 6, and then 7, 8. Correct?
Yeah.
Okay. This one, potassium becomes 288 and it becomes +1. So if you want to do dot here, then the other side must be cross. If you want to do cross here, then the other side will be dot. You have to draw it clearly. Okay, you can't just like, oh, it feels like having a 288. It cannot just suddenly feel like a dot, suddenly feel like a cross. Understand? So from 2881, now it is 288. And you cannot forget how to do electron arrangement because we did like so many of it. Okay? And then, okay, so this is now 288, correct? Then sulfur, 2, 8, 6. 1, 2, 3, 4, 5, 6, 7, 8. Okay? Got it. Do you understand now what you did wrong? Okay. And bracket 2 negative. Can you see? Get it now? Okay. Get it now? All right. So they expect you to draw it. K2S is the formula. Okay? Because K is +1, S becomes S2 negative. Okay? You understand now? You will practice a few more. Can you all go back and revise the electron arrangement, all that. Let's make sure you understand, okay? You cannot tell me your brain is fried, okay? Because I taught you all this for 3 weeks. I literally had one class with you Kim yesterday for 2 hours. We learned everything that you all learned for the last 3 weeks. One class. Okay, you're not paying attention. I think your brains are somewhere else. Because you're not smarter than this.
Wait,
Okay.
it's not that I'm daydreaming or something, anything. Every time I have science lessons, like, I go, like, it's one-on-one, and then, like, the teacher's being like, solve my questions, but mainly, it's listening, so.
Okay, no, you need to solve questions. This one is not a passive learning game. Okay, you have to listen, you have to do. And when I discuss, you have to draw. Okay? All right. Can't believe I have to check your work like kindergarten. Oh, okay, we need to do one more. Okay, what was the first one? Nitrogen, sulfur. Let me think. I'm running out of elements. Okay. Uh, okay, fluorine and oxygen.
What?
Fluorine and oxygen.
Is that fluorine plus oxygen?
No, they react together. I want you to draw a compound with fluorine and oxygen. It doesn't make a difference.
Oh,
Ah,
it's
ah.
like same.
Sorry?
It's like same as plus.
N. I wrote N. I wrote N.
Yeah.
Get it? Okay. Okay, so now with uh calcium and fluorine. Okay? What must you do first? Write down the
Oh,
electron
electron
arrangement.
first class.
Do you feel for your life?
I do fear for my life. No, you are not done. Oh, what? Both are wrong. What? This one is the only thing correct. The only thing completely correct is this. Only this thing is correct. If it, how can you suddenly change the electrons? 2882, in order to form a 2 positive, it gets rid of the 2, right? So 288 is all from calcium. Why do you dot and suddenly cross? And you're not even drawing 288. Like, what are you drawing? Draw again here, draw properly. This one is completely wrong. You didn't even do the how many bonds. Then I give you this for what? The one about the how many bonds? So you write down the list. Did you write it down just now? The one that I how many bonds? You didn't write it down.
No, I did.
Really? The one about group one, group four, how many bonds?
Four.
Where is it? There. Yeah. Then after that, I wrote the bonds. Did you write it? There's another one. The second one I drew.
Good one.
It's not here. It's on the book. I drew on the book. This one, this one.
Oh, that one.
This one. Here. There. Here. How many bonds?
Oh, that one.
So, the charge. What is the charge? 2882.
Yeah.
What does it do to say wrong? Because you didn't follow the bond. Okay, when I do, what do I do when I teach you how to do? Okay, I will first write down the electron arrangement. I will draw this first, then I will draw this. What makes your thing you can skip steps and then get it correct? Okay, so why are you skipping steps? Why is sulfur 2 bonds? Because over here, I wrote here, sulfur 2 bonds. Group 6. Do you remember how to look at the groups? The periodic. Then why are you not doing it? Why are you not doing it? Oxygen. Oxygen is 2, 6. How many bonds? How many bonds? 2 bonds. Thank you. Let's forget this. Okay. Fluorine, 2, 7. How many bonds?
Yeah, one bond.
1 bond. So shouldn't it be oxygen with 2 bonds like this? Why not try? Draw this first. You draw this first, then you draw the dotted cross. So this one, 2882 to achieve full outer shell. Group 2 becomes positive 2. And I say I keep repeating it, and then you ask me why I keep repeating it like this one? Cannot remember. Didn't I say it many, many, many times? Group 2, positive 2. How does it form positive 2? By getting rid of the 2. What are you drawing? 2, 8, 8. No more the 2. What are you drawing? And then bracket 2 plus. You show me what you're drawing. You're drawing
Oh,
2, 8,
I
2.
drew the final outer layer for the other
But
side.
you're supposed to draw 2, 8, 8, and then just a 2 plus. Right? It releases 2 to become positive 2.
Oh, okay, because it's only
So you need to draw 2, 8, 8. And then
Oh, I sent you the picture.
yeah, I just got it.
Yeah, correct. Okay, boys, I'm sorry, but the two of you need extra work. You go home, you must do this work, do it again, and then show me next week.
Okay.
Because you don't get it.
Next set is homework.
For you to, because you don't know how to draw. Come, show me what you did.
7. How many more does it need?
One more. So it's 1 plus.
Why have to give it more? Group 7, everyone, right?
Go home and refresh this. For the second I get home.
And then so from 2, 7, where's the
So the additional one should be.
but then you see here your calcium you do dots. So this should be crosses.
To show that it's the
And
different.
then the 7 one is a dot. Get it? This one is still wrong. But do you understand now?
Yes, a lot better than earlier.
And this one is still wrong. It should be it's correct. So it's wrong, right?
Yeah.
This one don't have,
Yeah.
So it's this and this,
Yeah.
Okay. Yeah. You know what? I think you didn't massage your brain when you came for class. Okay.
I think I can get perfect in next one.
Okay, come, let's discuss this first. Okay, so calcium 2882 becomes 288. Okay, 288. Today the weather not good, is it? Because last week you all were giving me all correct answers. What happened between last week and this week? So strange. You all like change personality like that. Huh? Last week?
Oh.
What happened? Too much holiday.
No, it's not that. I did too much studying before I came.
Too much studying. Okay, so your brain fried already. Okay.
Maybe if I come with a fresh mind without any electronic fog or like
Okay.
work up or anything.
1, 2.
The second I get home, I have to practice because
Okay,
I
no,
have
no,
to
no,
know
no,
what
no.
time to do.
You clear your brain first. Clear your brain first. Okay? Becomes 2, 8. 2, 1, 2, 3, 4, 5, 6, 7, and then the eighth one comes from this guy. Get it? Get it? Okay. Now the last one, fluorine 27, one bond. Guys, don't be lazy. Always write this down. Because you see, I writing it down, it's not that I forget, it's you forget. That's why I keep writing down the bond. Group 1, Group 2, Group 3, Group 4, Group 5. You need to write it down because you keep forgetting. Okay? So, oxygen must have two bonds. Fluorine, one bond. You get it now? Okay? So, I'm only going to draw the outer shell. Okay. So, you understand why you got this wrong? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then this one is 1, 2, 3, 4, 5, 6. Draw it bigger and draw it clearer. Okay? Get it now? Okay, draw this first. Okay, I'll give you one last one. If you guys can do this properly, then you can go home already, okay? You draw already? Draw already? Okay, let's try one more. So what have I given you, I have to give you something I haven't given you. Okay. Uh, I mean, I'm running out of ideas. Uh, I know. Okay, draw only the outer shell, okay? Only the outer shell.
Just with it.
I'm not able to, but you need to write down the electron arrangement, okay?
Yeah, because if you don't do that, you can't do it.
Yes, then you get confused. Okay? Kiddos, next week bring pencil, okay? Because you're actually supposed to draw dot and cross with pencil.
Okay.
Okay?
Because you're so funny lah. I scold already, you know how to. So every class I must start by scolding you, is it?
Oh no.
Huh?
No.
Huh? You're exactly like my students, like my other students. And then I have one student that actually made me record a voice note. Teacher, can you record a voice note of scolding me? I said, why? Then suddenly I have motivation to study. Then suddenly I scold you already, suddenly get you. Don't be like that. Can you imagine every class I have to start? I oh, teach all already, okay? I can't be scolding you and scolding you. This is a miraculously suddenly get everything correct. Huh? Oh, You cannot do like that. You have to know or don't know. I cannot be a trigger to make your brain work. Okay? Imagine then you have to carry me to your exam hall. Then I have to scold you.
Oh, I sent you the photo.
Oh, you sent me? Okay. you the second one is correct. The first one you got it upside down, my dear.
Oh, upside down.
Yeah. Four
Oh,
bonds and one bond. You got it the other way around. You look carefully.
wait, is the center the C? Oh,
Yes.
yeah.
You got it the other way around. You do it the other way around and correctly. The second one is correct. You home and do, okay? 6 to 1. So there you go. You find the bonds first. This is tiny because it's 2 6. It's 2.
Okay, 3%.
See? And the start very same lah. So already studied that I remember. Yes, you correct. I have to activate the brain, is it? You don't make me do that lah. At home, I school my children.
Yes,
Here.
my mom forced me to do homework and study at starting from 9 a.m. and until
So by now your brain burn already.
yes.
His brain is fried already.
Aiyo. Okay, next time take a nap.
I don't take naps.
Okay.
I don't get tired.
Okay, do the last one, do the last one. If you're done, then we can discuss.
Taking nap feel like wasted.
Really. Okay, when you guys go home and do this, the first thing you must remember is it ionic or covalent? Okay?
So if it has metal inside.
Yes. So faster draw. Last one already.
Okay, I think everybody got this correct, right? Okay, the first one, the magnesium fluoride. And this one, the formula is MgF2. Okay, can you all write the formula? Okay.
Bro, don't be so desperate to leave.
I'm not desperate to
Why are you holding your bag?
I'm just holding it, why not?
No, these are 4 bonds. 4
Oh,
bonds.
Use that. Draw all the dot and cross, make sure it's 9. Okay, so the last one, this one, okay, listen, just listen. Carbon is 2, 4, right? Fluorine is 2, 7. This one must have 4 bonds. You must start with this first. This one must have 1 bond. So 1, 2, 3, 4. 1, 1, 1, 1. Get it? Okay, can? So 1, 2, 3, 4. So carbon 1, 2, 3, 4. Fluorine 1, 2, 3, 4, 5, 6, 7. Like that. Do you understand? Okay. Okay, you draw first. If you're done, you can go first, okay? You understand? You understand? So the formula is CF4. Hmm?
if carbon has 4 bonds,
Hmm?
so when you drink that, there's 4 fluorine, but there's only 1 bond for fluorine. Why is that?
Because fluorine is 2, 7.
2 cents.
So it only needs 1 more. That's why we drew the list just now. This one, this one. This one, remember?
Oh, okay.
1 bond. How many bonds? 4 bond, 3 bonds, 2 bond, 1 bond. Okay? Okay? Okay, guys, go first. Did you draw this already or not?
Yeah.
You got this one you have. Okay. Bye everyone.
Bye bye.
Bye bye. See you.
See you.
I hope it does rain like last week.